Next problem is the control chart for count. Now, one of the important aspects of P chart and C chart is to be able to identify whether P chart is the correct chart or C chart is the correct chart. So oftentimes this is a question that students get confused about. Alright, so let's look at how to identify this. Now P is sample proportion. So you take a sample and you look at how many parts in that sample are good and how many parts are bad. So bad parts divided by the sample size will give you the P, and you compute P for each sample. But in the case of count, there is no sample. There is only the number of errors in one item. So this will normally be the case where you cannot take a sample of parts. For example, if you have in carpet industry, so you have like 1,000-yard length of carpet, now you're not going to be able to take 100 sample or even 5 of those 1,000-yard length of carpet and see how many are good or how many are bad and don't find a proportion. So in this case, you have to take a section of the carpet and count how many blemishes are there or something like that. Or it could be continuous wire, copper wire, for instance. Okay, again, you cannot take samples. You look at a section, then see how many errors or how many defects are there in the wire. So that's how you should identify whether you have several samples and each sample gives you X number of bad in the sample, in which case it is P. On the other hand, if it is just simply a count of number of defects, here is another example of why this is a C chart. So you have sports page in a newspaper and you're counting how many typos are there per page. So you start a sample, it's in one page, how many typos are there. So that's so C is count of typos, and we have that here, and sum is 15, and there are 6 days here, so C bar is 15 over 6 is 2.5. Then we want 99.73% chart. Z is 3. Okay. And the formula is C bar plus or minus Z times square root of C bar. So our lower control limit for C is 2.5 minus 3 times square root of 2.5. So that is minus 2.24. Remember, can be negative. Therefore, lower control limit is 0. Upper control limit is 2.5 plus 3 times square root of 2.5. So that is 7.24. So the control limits are 0 and 7.24. And I've already plotted the samples. So our lower control limit is 0, upper control limit is 7.24, but C bar is 2.5. The process is in control.